All right. Looks like we're live. Good afternoon, everyone. Thank you for attending and joining us today for our third webinar in our ongoing series of power generation webinars. Today, we'll be presenting the lessons learned on a DCS upgrade for a power plant located in the Ohio Valley region. At any time, if you have any questions during the webinar, please feel free to type them up in the webinar ask session, and we will address them at an appropriate time. Please go ahead and go to the next slide. So today, for our webinar, we plan on presenting the following. First thing, we'll be introducing Entrust Solutions, overview of our automation services. Secondly, we'll be introducing the presenters, the EM power generation teams, specifically Alan Burck and Tyler Brown. Alan will be jumping into the beginning part of this presentation, which is the history of the presentation, a history of East Bend and why they needed this upgrade. Tyler will then jump into and present the scope of work, the responsibilities, the timeline, schedule, challenges, and successes that occurred during this project. And then finally, the overall meat of this presentation, the lessons learned and items that can be used for any plant's next control system upgrade. Go ahead and go to the next slide. Thank you. This is just a brief overview of Entrust Solutions as a whole. I'm not going to go through all the numbers here, but I just wanted to convey that we are a big organization, and we definitely have a lot of skill sets that potentially can help out with your plant's issues. Please jump to the next one. Thank you. These are our offices and regional offices that we have within Entrust Solutions. We have a lot, even in Canada, so I'm sure we'll have people nearby your guys' plants or facilities that can help out with any of your needs as required. Please go to the next one. Thank you. And this is an overview of our skill sets from a power generation automation point of view. As you can see here, our main skill sets are programming, so PLC, DCS, and HMI, SCADA system design, control system migration, modernization, control panel design and fabrication. The emphasis on fabrication as well. We do have a panel shop, so we can procure parts, build them, and test them at our panel shop. We can do drive control, upgrade roadmap developments, phased approaches, turnkey system installations, commissioning and startup services, industrial utility networking, technical support, low to medium voltage power distribution, instrumentation systems, and other skill sets that are not listed on here as well. If you guys have questions on some of these skill sets or what we can do, more than happy to break up and discuss that as well. So we have developed strategic partnerships with key vendors and technologies to assist our end users and clients. And these are a main focus of some of our clients that we, not clients, but some of our vendors that we've partnered up with. Inductive Automation, ABB, Rockwell, Siemens, Mitsubishi, GE, Esri, Aviva, and we're also certified as a Control System Integrator Association, CSIA, as well as ISO 9001-2015. Now, bear in mind, this presentation will be focused more on Emerson, specifically Emerson Ovation. So we definitely have that expertise as well, which was not listed in our partnerships and vendors. An overall introduction of our presenters. So I'd like to present Alan Burck and Tyler Brown. Alan Burck will be focusing on the history of the plant. And he'll also give himself a brief introduction of himself and his past experience, as well as Tyler Brown, who will be focusing on what happened and the lessons learned and any other questions that come up during this. So, Alan, I will pass it on to you.
All right. Thank you, Matt. So Matt mentioned, I'm Alan Burck. I've been with Ian Engineering about 4 years. Prior to that, I was a long-term Duke Energy employee. So at Duke Energy, 37 years, always in power generation, always at a power plant. So what I was going to talk about is the background of why this upgrade was necessary for Duke Energy to do this, and hopefully by going through some of the background, you get a better appreciation for some of the struggles and obstacles that DCS owners face in power generation. So East Bend, it's a single unit, 650 megawatt coal-fired power plant. Went into operation in 1980. It was originally built with a Leeds and Northrop analog control system. And sometime in the early 1990s, their turbine control was replaced with a Bailey ETSI, so INFA 90 control system. And the plant stayed that way for the first 20 years of its life. Early 2002, the plant, they decided to get away from their Leeds and Northrop analog control system, just because of the high maintenance of it and lack of repeatability of some of the control. So they made plans to replace their LNN analog control system with an Emerson Ovation DCS. And they used a Solaris or Unix operating system in the original installation. So the original control functionality that was integrated into their control system in 2002 included combustion control, turbine control was integrated, boiler feed pump turbines, burner management. They were installing a new SCR, selective catalytic reduction for NOx emissions, NOx control. That was integrated, integrated or balance of plant control. And that included taking all the control switches off their original panel board, and all the control switch functionality was integrated into their Ovation DCS. We also integrated SIP lower control and data acquisition. So after that outage, East Bend continued to add control systems or systems to their DCS control system. Over the past 20 years, they've integrated their flue gas desulfurization system, or FGD. They integrated line barge unloading, coal handling, fly ash from their precipitator, integrated lime injection, water chemistry, and most recently, during their last outage, they integrated dry bottom ash. So by 2020, almost the entire plant at East Bend had been integrated into their DCS, and it had grown into one of the largest DCS installations, Ovation DCS installations for a single unit in the country. So originally, when East Bend installed their Ovation DCS, Emerson only offered a Solaris operating system, a Unix operating system. But customers continually ask for a Windows-based Ovation control system, and that prompted Emerson to develop a Windows version sometime in the early 2000s. And it was originally introduced as either Windows XP or Windows 2000. Emerson recognized that we live in a Windows world, and demand for Solaris was dwindling. And shortly after they introduced the Windows operating system, customers just flocked to the Windows operating system, and eventually Emerson discontinued all support for their Solaris operating system in 2015. So with the Windows operating system, that presented a new set of challenges that Solaris didn't have. There were a couple high-profile significant events that occurred in the United States in the early 2000s. 9/11 occurred. The U.S. government recognized the vulnerability of the U.S. power system to cyber attacks and terrorist attacks. it was an uncertain time for the country. So NERC issued a urgent action standard in the year 2003. Later became the initial SIP standard, critical infrastructure protection standard for electric utilities. Blackout occurred in the Northeast in August of 2003, and it increased the urgency of the need for protecting the U.S. Electric power grid. One of the first thoughts when the blackout occurred is either a terrorist attack or it was from somebody hacking into a control system. So 2005, NERC was designated by FERC, the Federal Energy Regulatory Commission, as the electric reliability operator for the U.S. power grid. So they have oversight responsibility for the U.S. power grid. And the most important part of it is NERC standards became mandatory. Up until that point, NERC would create standards. The standards were highly recommended. They were good practices, but there wasn't a regulatory agency that enforced it. So when FERC gave NERC this responsibility, they also dictated that NERC standards are now required for electric utilities. So in order to comply with the new NERC SIP requirements, owners of Windows-based control systems used in electric utilities are now required to implement Windows security patches monthly and any Ovation patches to address any potential vulnerabilities or any threats that may exist. Microsoft will typically release a new operating system every 3 to 5 years. They'll support the previous operating system for someplace around 10 years. So when Microsoft no longer offers, when they end support for an operating system, a Windows version, and they no longer offer security patches, Windows users are unable to fully comply with the NERC SIP requirements to do the monthly patches. Any new vulnerabilities that will be discovered in discontinued Windows operating systems, Microsoft would not create a patch for it. So as Microsoft would introduce new versions of Windows, Emerson would validate the version of Ovation, make whatever updates are necessary to be compatible with the new Windows version, and they would release a new Ovation version level. Emerson offers a program that's called Evergreen, and that is intended to update the Windows operating system on the operator workstations. Updates the Ovation software level to bring it to the current level, and updates all the network switches, replacing all the workstations. So eSpin's first Evergreen update was in the year 2012. I mentioned earlier that Emerson had already published the end of support date for the Windows Solaris operating system. It'll be discontinued in 2015. So eSpin had to get away from the Solaris operating system. 2012, they did a Solaris to Windows migration. And all the original controllers, the power supplies, all the I/O hardware, all of that remained unchanged. They just did the Windows platform migration and updated all their workstations and network switches. So by 2021, the Windows operating system that the eSpin had, they installed in 2012, was near the end of support life for Microsoft. So in 2021, eSpin was again due for their next Evergreen update because Microsoft was going to be ending issue of security patches for the operating system they had. So East Bend needed the Evergreen update to update their Windows operating system so they can fully comply with the NERC SIP requirements. So EN Engineering or EN Automation's role was to we function as the owner's engineer for Duke Energy to help Duke Energy manage and implement the 2001 Evergreen update. So that's kind of the quick history of East Bend, why this was necessary, and also why these upgrades they're going to be continually needed at sites. So before we continue on, does anybody have any questions? All right. Well, at any time, if anybody has any questions, just feel free to enter it in the chat and or the questions and answers, and we'll address your questions. Tyler, it's up to you.
All right. Thank you, Alan. If anybody has any questions, someone just kind of reach out and let me know. So like Matt mentioned earlier, I'm Tyler Brown. I was the engineer on this project. Been with Entrust Solutions Group for just about 4 years now. So I'll go over the scope of work and kind of some of the struggles and successes that we had throughout this project. So previously, East Bend had Ovation 3.5, and the goal was to upgrade them to Ovation 3.8. And Ovation 3.8 comes with the upgrade to the OCR 3000s, which is the new controllers that Emerson's producing. And those have a little bit different way that they communicate with the remote nodes. They use RNIs. That stands for remote node interface. So those were all replaced during this as well. So while we were doing that, since all the controllers had to be taken off, taken out of service and replaced, we wanted to upgrade all the power supplies to the latest version of power supplies that Emerson was offering, partly due to just the age of the original power supplies that were in there. Some of them have been replaced due to failures. A lot of them were original. So it was just a perfect time to go through and replace all those, since we were going to be right in there anyways. We also upgraded all of the network and route switches throughout the plant that the network uses. And like I said, replacing all the remote node controllers, those are the RNCs with RNIs. It's just a new version of how Ovation communicates and controls the I/O on the remote nodes. Then we also replaced and upgraded all the operator workstations. So that's all the servers that support those, as well as the monitors, mouse and keyboards, KVMs, everything like that. Just because everything was going to be off at that time, and it made sense to go ahead and upgrade all of the monitors just to avoid any future failures or anything, just due to the age of them. So there's kind of the numbers of this upgrade. Like Alan mentioned earlier, so it's a particularly large system, especially for a single unit plant. There's 24 controller pairs. Those cover just about everything in the plant is controlled by Emerson Ovation, excuse me. There's almost nothing that's just locally controlled at this plant. So there's 25 remote node interfaces that were previously the remote node controllers. Those are split up between 12 of the controllers, so half of them have remote nodes. And of those 12 controllers, there's 25 remote nodes. So some of them have 2, some of them have 4. There was 20 operator workstations that we replaced. So those are located throughout the 3 main plants. East Bend's kind of split up into main steam, FGD, and WSP. Those are kind of the 3 main areas that have network connections, and those are where the controllers are kind of centralized. So in those areas and throughout the plant, there's 20 operator workstation 6 engineering workstations. So those are used for making any engineering logic or graphic updates, as well as 8 additional servers. Those are used for various things like playback, the historian, combustion optimization, and Pi. So like I mentioned, there's actually 4 plant interconnected server locations. The 3 are at main steam, FGD, and WSP. The 4th one is actually in the service building inside the system owner, the DCS system owner's office. And they also have a test drop. That's one of the 24 controller pairs that doesn't have anything connected to it, but they can connect in different IO cards and set up logic and test it in there, as well as a remote control station in the event of an emergency. So that's located in the service building, external to the normal operating room. And then the fully redundant power and UPS backed up. So that refers to just the power distribution of keeping redundant power to every server and every controller throughout the plant. So we went through and kind of optimized the connections and made sure that everything was on redundant, and one of which is a UPS backed up power for every single server. So EN's scope of work, like I mentioned, we were responsible for the power distribution design and drawings. So we had someone on our electrical design team. He was responsible for all of the drawings and all the design work for this project. He helped out in the planning and throughout as everything came up. We updated all the control network drawings. This was Emerson provided the preliminary plan of how they wanted the network to connect. We were responsible for designing how it was actually going to lay out into their drawing set, create all the drawings for it, address all the third-party network connections that were necessary, kind of the finer details of how it's actually going to work and connect at East Bend. So we created drawings for all the workstations, showing all the new monitors, how those are connected, where all the power is going to be fed for all of those. We are also responsible for the material procurement. So this is everything from network cabinets to KVM, fiber extenders, video extenders, anything that goes inside the server cabinet that supports the operator workstations. A lot of the fiber material that was used throughout connecting some of the remote nodes, mounting brackets for the monitors, everything like that. We also provided pre-outage, installation, and startup project management. So I was there throughout the duration of the outage, support any questions or issues or roadblocks that came up while trying to install these upgrades. So the total final drawing count was 390, if that kind of helps put it in perspective. Just the number of different areas and drawings that we had to touch just to integrate all the changes that we made. So one of the items that wanted to be addressed during this project was upgrading the existing fiber network. So previously there was a multi-mode fiber network that was used for all the control system, and kind of a way to hopefully help extend the life of our efforts. We installed a new fiber network that was all single mode, gigabit capable, to hopefully support any future network needs. And we also kept the previous multi-mode fiber network as a backup to use. ITOT currently uses it, and it's kind of used as like a spare or any other fiber needs that the plant may have in the future. We left that in there and intact and available for use, but we moved all of the network over to the new gigabit capable single mode. And like I said, upgrade of all operator workstations, adding additional engineering and operator workstations. So we added a couple of engineering workstations kind of throughout the plant in areas that were important to have. I know during some of the outages, if you have multiple people in there working on different projects, we wanted to add additional engineering workstations. So when it's kind of crunch time and everybody needs to be in the same spot, that would help alleviate some of that pressure. We did the addition of a new remote node and a relocation of an existing drop. So this was an interesting one. One of the drops is located in an external building, kind of off by itself. It was key card access only, but it does have roll-up doors there, and kind of to comply best practice of NERC, it was best practice to move that drop up to where all the other controllers are, and make that a remote node. So the physical controller itself wouldn't be out there. It's just a remote node controller. So the way we did that is, since there was already fiber ran all the way down there, we installed a new controller upstairs with all the rest of the controllers, and actually made the IO that was originally the local control IO. We made that a new remote node, and ended up working out pretty great. And it left them with a blank drop upstairs that they're available to add IO to in the future. We also upgraded the redundant power feeds, like I said, to all the network switches and servers throughout the whole plant. We were also there available for Ovation graphic and logic modifications. Some issues came up during the conversion. Some of the graphics didn't come out looking the way that they had looked previous Evergreen update. So we, in spare time, made Ovation graphic and any logic changes that some of the operators had some wish list items that they'd like to get done. So we were available to help them out, make some of those modifications as time allowed. So the timeline and schedule, I'm not going to go over the exact timeline that was used at East Bend, because the timeline is always kind of dependent on what else is going on at the plant. But instead, I'm going to go over kind of the three major phases of the schedule and what we did to be successful. So during the pre-outage, we planned the order of the controllers to be replaced as best as we could. So just kind of looking at the outage schedule, what equipment needs to be available during whatever is tagged out, and what equipment needs to be available pre-outage to start up. We did the procurement of materials during this time, as well as the order of the replacement of components in the control room. And one of the things that we did that really ended up helping out during pre-outage was setting up a material staging area. So there's actually a building that was just outside of the control room on a lower level that no one was needed to get into during the outage, and it was secured by badge ID access only. So it was a perfect spot for us to store all of our material, all the servers and network equipment, and we were able to store any of the old network equipment that we were removing in there. That way it was somewhere secured that only certain people had access to. So that was extremely helpful to have that, be able to set that up and be ready to go for the outage. So during the outage, it was important for us to be able to pivot and adjust our plan to meet the daily changes in the outage schedule. So we had to be present during the daily outage updates, because I know, as most of you probably know, the outage plan typically never goes exact. So being able to pivot depending on who's running behind, who's running ahead, be able to take different areas of the plant offline and get different areas back online at different times than we planned, was crucial in not getting in the plant's way as far as startup and outage support. So post outage we used for tidying up any cable management that was kind of put in quickly. For instance, if we had a system that they needed up that was kind of unforeseen, they said we need this back up today, and we kind of hastily put that back together. We took the time post outage to kind of tidy up some of that work, as well as installing any non-essential workstations. So some of the excess engineering workstations or operating workstations that aren't really used much, we're kind of able to push those off to the end and do a little bit more critical work during the outage and finish the installation of those less essential workstations post outage when no one really is in a need to have those right away. So some of the challenges that were faced, obviously this was the first installation of the OCR 3000s. So we had some issues getting the communication working between the OCRs and the RNIs, just because Emerson had really never commissioned these on site before. So just the first couple of them, trying to figure out what exactly they need to get communication established and get it off and running. That was something that we definitely needed to allow more time for. If this was an upgrade to a platform that Emerson had done 100 times, then probably don't need to allow excess time for that. But since they hadn't really had a lot of experience with these at that time, that was something that ate up some of the scheduled time that we had. Just the availability of space for the installation of all the equipment. So the server room where all the servers are located is a very, very small square footage area, and we had as many people as we could get in that spot for installation. But again, you can only fit so many people in there, so there's really no availability of adding manpower to get more done in a shorter time frame. We could only fit so many people, and on top of that, ITOT was doing a project in that same room. Thankfully, we were able to finish and coordinate our times so that we weren't in each other's way. But they had 7 people in there, and that's about the capacity of that room. Another issue that we ran into pretty frequently was bad existing fiber. So not aside from the network fiber that was used, we used some of the other existing fiber to run out to remote control workstations. So for example, the LBU, the line barge unloader, and the coal barge unloader, those are a couple miles away from the actual server itself, and we were planning on reusing those fibers. But the issue we found was the resolution of the new monitors required more bandwidth, and those fibers just weren't able to support. Some of the fibers weren't able to support the new monitors and the new KVMs that we were using. So we spent a lot of time cleaning, replacing ends on fibers. So one of the things that we would have done is just plan any existing fiber that we're reusing, plan on putting new ends on every spot that we're going to reuse, and set aside that time and material, and maybe do that pre-outage as available, or as soon as the outage starts, get in there and start replacing those fibers. It would have saved us a ton of time, particularly in some of the areas like heading out to the line barge unloader. Some of the places it stops is extremely dusty, and it's you could kind of expect there to be kind of some issues with some of the ends of those fibers. So the monitors that were used to replace the old workstations, we used 4K monitors. We had some issues with incompatibility with different KVMs and some of the graphics that Emerson had used previously. We had to spend a good amount of time correcting some of the graphics just to make them look the way that they should. And that was kind of one of the lessons that we learned, is these graphics were designed originally in the early 2000s, and they weren't really it's really moving up to a 4K doesn't change the way that these graphics are going to look. They're not going to look any better because they were only designed with such a certain resolution. So the 4K monitors kind of caused a lot of heartache throughout this project, just trying to get the capability to get those to connect and function correctly, when in reality we ended up having to run those at a lower resolution just to make the Emerson graphics compatible. So keeping the previous network running throughout the entire project, this refers to keeping the old multi-mode network up. So as we did this installation, we actually kept every system online on the old network until it was time to upgrade it, and then at that time we switched it over to the new network. So throughout this whole project, we had two system networks running. So anything that hadn't been upgraded was running on the old network, and everything that was on the new network. So there's two identical networks running, and that actually worked very well. We were able to keep tons more equipment and service throughout this upgrade than we would have been able to if we had to take out the old network cable first. So even if we were planning on removing the old multi-mode network fiber, it would have been beneficial to keep it until everything was transferred over. That way we'd have access to any systems that the plant may need. And then there was a lot of incomplete existing drawings, particularly with third-party network devices. Going through the drawings, we ran into a lot of things that were either not there anymore or something that was there that wasn't reflected on the drawings. So that posed some extra time for us during the drawing phase of this. So some of the successes that we had, like I mentioned, keeping as many drops available for operation. We did this utilizing the old multi-mode network system, and this kept everything that had not been upgraded yet running on Ovation 3.5. So we had to keep the engineering workstation and the database for the old network. We kind of moved it over to the side and kept it running, and then kept the connection to any drops and servers that were still connected. I think we kept one server in the control room running on the old network, just so the operators could, if they needed to, run any equipment that's still on the old network. And that was definitely something that we had to keep communication with operations, letting them know which system is now on the new network and which is still on the old. That way they're not trying to start something that may be on the new network and they're trying to start it from the old network. But that ended up working out great. We kept everything really only upgraded one drop at a time, one controller at a time. The timeline, we were able to meet the outage requirements. We actually finished a little bit early, and we didn't get in any way of anybody else's projects that they were trying to start up and commission. The logic and graphic migration worked out great. Emerson did a migration from the old system to the new, so they took the most recent backup as soon as the outage started and converted it, and that ended up going great. There was only a few graphic issues, particularly that wasn't particularly Emerson's fault. Most of that was due to trying to make them work with 4K monitors that actually caused the issue. And then the cleanup of abandoned cables. So there's actually cables from the original operator workstations that they used in the 2000s that were either cut or just abandoned, coiled up under the floorboards. So we spent a lot of time at the beginning of the outage, once we kind of removed most of the operator workstations, going through and marking what cables weren't needed and pulling them out and getting all of that cleaned up. And that was definitely key for us to be able to get all the new cables that we needed to get back under that area. So we'll go through some of the lessons learned, and these are lessons learned that we kind of sat down at the end with Duke and everyone involved and kind of created a list of all the lessons that we learned. So better scoping of the evergreen equipment. This kind of talks about there was a lot of equipment that was kind of unforeseen by everyone. So really just sitting down and thinking about everything that needed to be replaced and what it takes to do that. So every display cable that needs to be replaced, making sure that that's actually compatible with the monitors that you're going to be using. We used something. It's a fiber video extender, and it was not compatible with most of the monitors that were purchased. There was a bad flickering effect that was pretty noticeable as soon as we connected our first monitor. So about half of them we actually had to return and replace, and that was kind of a fiasco, just because at the time, this was I believe it was in 2021, the supply chain was still not what it could be, so that posed a lot of issues. More complex Ovation systems require more than one walk down, and this we found to be true, mainly because there was just so much to this system, like Alan had mentioned earlier, that it's hard to kind of grasp the size of everything that needed to be replaced with just one walk down. It would have been better to do multiple and really dig deep into every single system that we're moving and touching. So the system registrations didn't collect all the necessary information. So this is some of that migration that Emerson did. Some of the values didn't get transferred over, so there was a lot of time spent combing through and figuring out what didn't get transferred over. The network drawings, I mentioned this earlier, a lot of the third-party network devices were not represented correctly on the drawings. So this caused a lot of confusion when we went to install the new network back in. We kind of realized we were looking for devices that didn't actually exist, that weren't actually there previously. So kind of determining what was actually there and what was not kind of posed a bit of a challenge. So really going through, digging deep, and finding exactly where every third-party device is connected and where it needs to be connected, and labeling all those cables and getting them on a drawing is definitely something that we would have paid more attention to pre-outage. So the system changes, post-software freeze needed to be validated. So this talks about some of the system changes that were done after Emerson created the backup that they used to recreate it in the new Emerson or the Ovation system. So somebody made a couple of changes after that snapshot was taken, and it kind of made it difficult to go back through and figure out what was edited and what needed to be implemented on the new system. So the new technology use with Evergreen system requires closer coordination with vendor product availability. The material available significantly impacted project delivery schedule. So this is kind of alluding to some of the display cables that weren't, like I mentioned, that weren't compatible with the monitors. And it would have been good to know that and double check that everything is going to work together when you're ordering things from multiple vendors. So again, the third-party network links, those are just something that needed to be combed through with a finer look. And then specifying sizes of display devices. Some of the resolutions were off using the 4K monitors, and that's something that it would have been nice to check with Emerson and see what exactly the capability of their graphics are. So we could have bought the resolution appropriate monitors. So just the size of this unit required more tracking and oversight during the installation. Just one of the things that was reflected, it would have been helpful to have more oversight on where all the new equipment is being moved each day in and day out, and what new equipment is being installed. So the better understanding of the new technology. This is the first evolution of the OCR 3000s, and there was some installation and startup headaches that we kind of went through that Emerson and Duke hadn't really experienced before with these new controllers. Ensuring all the project drawings are available prior to the start of the outage. So we were kind of thrown into a pickle a little bit. We weren't able to start on this project until maybe a week before the outage. So we were kind of thrown in a little last minute. So what we did to overcome that, we looked at what needed to be done first, what work was going to be completed first, and then kind of moved from there. So we looked at the new network system first, and we attacked that, and then we kind of moved on to replacing the power supplies and updating some of the other drawings that weren't going to be affected until someone looked at it in the future. So again, the third-party network issues. There was changes to the third-party network were limited to replacement of hardware. There was a bit of a misunderstanding between the third-party uplinks. Needed to know that we needed to change those to 1 gigabit speeds. So that was kind of one of the struggles that we faced when we were starting up the new network. So like I mentioned earlier, just plan on all the fiber connectors at each patch panel needing to be replaced during the outage. There were significant problems with existing fiber and the kind of the quality of the connection that we were able to get through it. I remember spending a lot of time hopping from fiber to fiber to try to find a pair that would work correctly. Ensuring there's enough server workstations for anybody that needs access to it. So at one point we had several Emerson employees there working on various different projects to get this started back up, and we kind of got bottlenecked by the number of workstations that were available for them to do that work. And then need to ensure that non-evergreen installation materials are procured and delivered prior to outage start date. So this talks about kind of all of the network display cables, just the display cables, any specialty connectors that are used to connect servers to different components. Having those pre-outage would be ideal. Again, this was kind of something that we ran into a supply chain issue, just due to the nature of the time that this project was completed. So I already mentioned the replacing all the ends on the existing fiber and verifying the compatibility of monitors to display cables, servers, and software. So we had to spend a lot of time going through each server, updating the resolution, and then updating the resolution to make it work correctly with the Emerson graphics that were already there. So I've just got some photos of the old versus the new, just to kind of give you a visual and kind of talk about some of the specifics of how this works. So on the left, this is the old controller. This is actually drop 26. This is the controller that was moved from that kind of remote building up to where all the rest of the controllers are. So this is what it looked like previously. Got your media converters up above. One of them actually converts the fiber to Ethernet, and that's the network connection to the root switches. And then the other 3 go to the remote nodes. And then on the right, you can see that's the new Ovation controller. And There's IE 2000 switches that are used to connect to the remote nodes. So kind of the way those work, those are redundant IE 2000s. So each one of those blue pairs goes to one of the remote nodes, and then there's a ring connection to connect those to make them fully redundant. And actually on one of the drops, there were four remote nodes. So we had to have 4 IE 2000 switches, and those were kind of ring connected together to provide the redundancy that was necessary and all the port connections that were needed. And this on the left, that's the new remote node interface. So it actually looks just like a controller, but you can see your remote node connection, that blue fiber coming in, that's the fiber from right here, comes into your primary and backup. So one from each of the IE 2000s. And then on the right is the new power supplies that were put in for every branch. All right, and that is all I have. So I will try to get to the questions and comments section here. So feel free to add any questions, and I will see if I can find them. Should be able to. All right,
Yeah,
there
so
are
as
no
of
new
right-
questions.
Yep, I was about to say that too, Tyler. Yep.
So I'll stop for a little bit. If anybody has any questions, feel free. If you want to know more about the history, I'll volunteer Alan to speak more on that. He knows it better than anyone.
Well, thanks, Tyler. Yeah, so we'll stay on here for a few more minutes to see if there's any questions or comments or anything that comes up. But in the meantime, definitely appreciate everyone joining this webinar, and this will be an ongoing series that Intrust will be doing. So we'll stay mute here for a few minutes here, and then we'll drop off here. Tyler, I actually have a question for you.
Sure.
What was the longest lead time issue that you had? Was it the cables? Was it the monitors? What was something that a power generation plant should really look at based off of what you guys were running into from a lead time point of view?
Actually, funny enough, I think the item that took the longest to get there was some of the mounting brackets for some of the monitors. It's not really too urgent. We were able to kind of push those off for at least less important areas, but I think that was probably the worst lead time with some of the mounting brackets. We did have an issue with some of we used a specialty fiber display extender, and those were made to order, specific length fibers. They were display port on each side. And actually at the beginning of the outage, one of the electricians didn't really pay too close attention to what kind of cable it was. Pulled it through the seal tight, pulled it up to where it about needs to go, and cut off the ends. Well, there's no way to put those ends back on, so we had to actually order several more of those, and it was just a honest mistake, just kind of force a habit doing that. But that was something that we weren't really planning on ordering more of those, but thankfully we were able to get on and order. We actually ended up ordering a few spare just for any future future issues that may happen with those. But those were, I think those were a couple weeks, so it wasn't that quick. But thankfully, it didn't cause any huge upsets.
Gotcha. Thank you, Tyler.
Yep.
Well, I think we will call this quits. So, Tyler, could you move it up one more slide?
Yes, I think I can. Here we go.
Perfect. So we've laid out email addresses. So if there's any questions that come up to mind after this presentation, feel free to email any three of us. We will address that. And in the meantime, have a great afternoon, everyone, and thank you for attending.
All right, thanks everyone.